Hello everyone, I hope you're all doing well. So today's lecture is on trying to find a solution to some word problems. We've looked at what a system of linear equation is, and we've also looked at why we want to consider it. And the main reason is because it helps us to solve some of the word problems that we have around us. If we want to make a decision, we know that we can simplify that decision into a mathematical formula and then solve for the unknowns, and this will help us to make informed decisions. All right, so we want to look at problem number 1, which says the length of a rectangular garden is 3 times the width. What are the dimensions of the garden if the perimeter is 32 meters? So what do we know from this? We know that there's a rectangular garden. So to help us solve this problem, or to make it easier, let's find a pictorial view of what the problem is. So first, we know there's a rectangular garden, and we've been given the dimension, which the width, and it says that the length is 3 times the width. So if the width is W, then the length will be 3W. And since it's a rectangular garden, it means both sides are the same. So if you have L is equals 3W up, it means we also have L is equals to 3W and a W here. We've also been given another parameter which says the perimeter is 32 meters. And what is a perimeter? Perimeter is the total distance around the object. So if we find the total distance around this rectangular garden, we have W plus 3W plus another 3W. And this is called the perimeter. That is the total distance around the object. And in the question, this is equal to 32 meters. All right. So adding all these, we have 8W equals 32 meters. So to find W, divide both sides by 8, and this gives us 4 meters. So the width is equal to 4 meters. Therefore, the length, which is L, which is equal to 3 times W, this is equal to 3 times 4 meters, and this is 12 meters. So the length of our rectangular garden is 12 meters, and the width is 4 meters. All right, so using the same procedure, I want you to go through or try out problem number 2 up to problem number 4. And let's take a look at problem number 5. It says a landscaping company placed 2 orders with the nursery. The first order was 13 bushes and 4 trees. Okay, so if we let T be equal to trees and we let B equal to bushes. Now it says there are 2 orders, which is the first order and the second order. In the first order, we are placing 13 bushes and 4 trees, and the total is equal to $487. They also have a second order, and the second order we are placing an order for 6 bushes and 2 trees, and the total is $232. All right. Now the question is, the bills do not list the per item prices on what were the cost of 1 bush and that of 1 tree. So we have to find the value of B and find the value of T. From here, we know that we have 2 systems of linear equations with 2 unknowns. And then the second one, which is 6B plus 2T equals to 232. We have 2 linear equations with 2 unknowns, and the unknowns are T and B. All right. Now we've discussed some of the ways or the techniques that we can use to solve a system of linear equation. So the technique that we'll be using here, looking at the 2T and 4T, what can we do to make sure that we eliminate T? Now we know that to eliminate T, I can multiply equation 2 by an integer, which is -2. So that I'll have -4T and positive 4T. So if you add 4T and -4T, you're simply eliminating the variable T. All right. So equation 2 multiplied by -2 gives us -12b minus 4T equals to -464, maintaining equation 1. for t equals to 487. All right, so if we add these two equations, we have 13b plus negative 12b. This gives us a b. Then the second part gives us 0 because we have positive 40 minus 40, and this is equal to 23. So we have b to be equal to 23. Doing a back substitution, we have b equals 23 into equation 2. We have 6 into 23 plus 2t equals to 232. So making 2t the subject, we have 232 minus 6 times 23, and t equals to 47. So in total, we have the cost for one bush is $23, and the cost for one tree is $47. All right. So with this, you should be able to solve problem number 6.